Welcome to Brain Vision.
To find the increase in area, let's start by finding, the final area. We know that our length increases by delta L and our width increases by delta W. So we can use linear expansion to find our new length and width. So for width, W plus delta W, same thing as W final, is going to be equal to initial width W times 1 plus alpha delta T. Similarly for L, we'll have L plus delta L is equal to L 1 plus alpha delta T. Now our change of area, delta A, which we want to find, is going to be equal to our final area, AF, minus our initial area, AI. And this is going to be equal to, our final area is going to be the length and width final of our new rectangle, which is going to be W times 1 plus alpha delta T times length times 1 plus alpha delta T minus our initial area AI. Now you should be quick to notice that this times this is just going to be equal our initial area, right? So our change of area is going to be area initial times 1 plus alpha delta T squared minus area initial. Now we can do out this quadratic. Find that delta A is equal to initial area times 1 plus 2 alpha delta T plus alpha squared delta T squared. And then we're going to have a minus 1 because we factor out that AI on the right side. Notice the ones will cancel, and we're going to make the assumption with this. This is actually kind of for part B, but I'm going to say right now that this goes to 0, and I'll explain why in part B. So we're left with delta A is equal to 2 alpha initial area delta T, our desired equation. Now for B, if we wonder, okay, the assumption we need to make that A squared delta T squared goes to 0, we need to assume that alpha squared delta T squared are very, very small. And so when we add them next to a 2 alpha delta T, there it essentially does not affect our area at all. So we're assuming that alpha delta T is very small.